Guys, good afternoon once again. Today we are going to take another topic in mathematics, which is called mensuration. Mensuration. So we are going to go straight into the topic without wasting much of our time. I've told you our topic, our textbook of use here is New General Mathematics. And if you have any topic you want to, any textbook you want us to make a video on, please drop in the comment section. So today we are going to be looking at mensuration for SS3 class. So we are going to get right into the business. Example 1. Example 1. So it shows a doorway made up of a circular arc ABC which subtend an angle of 60 degrees at center O. Two upright line CD and line AE of length 4 meter and the horizontal base line ED 3 meter wide. Anyway, this is what we need. Let me give you the diagram of the question A. So this is how the diagram looks like. So this is 3 meter, this is 4 meter, this is 4 meter. So this is C, this is D, this is E, and this is A. Okay, and here we have a curve or an arc, so which is B, and this is an extension. So now go 60 degrees. Now the first question is that we have to show that the perimeter of the doorway is 11 plus pi meter. So A, show that the perimeter of the doorway is 11 plus pi meter. So now the task ahead of us is to show that the perimeter of the doorway is 11 plus pi meter. Now, this is the doorway, this is the entrance of the door. So this is the doorway, and these are the sides of the door. So if we are to get the perimeter of the doorway, we are going to add all the sides of the doorway put together. So what this question is actually telling us is that if we add all these sides together, we should show that the result we are going to get is 11 plus pi meter. Now, when you ask to find the perimeter of any shape, now let's say you ask to find the perimeter of this rectangle. This is length, and this is the breadth, okay? Or this is breadth, or this is the length, whichever way. So the perimeter is the addition of this side with this side with this side and this side. So perimeter is to add all the sides together. I hope that is clear now. So now, how do we get the perimeter of this? By adding CD, DE, AE, and AC together. Now, the perimeter is not talking about the internal aspects. So the perimeter is the external side that we're going to add together. So now, if you look at this diagram, we already know DE. We know this side to be 3 meter. We know this side to be 4 meter. We know this side to be 4 meter. But we don't know AC. We don't know this arc, length of this arc. So what we are going to do is that we are going to take advantage of this cone to find this arc. So if you go to this particular topic that talks about length of arc, so you will know the methodology we use to find the length of an arc. Remember, the length of an arc is given by theta. That's the angle of the arc over 360 degrees times 2 pi r. So now, length of the arc, if you have to find the length of this arc, it will be theta, which is this angle here, which is 60 degrees over total angle in a circle, which is 360 degrees, times 2 times the value of our pi. The value of our pi is 22 over 7, but we can choose to leave it as pi because according to what we see here, we see that the pi is one of the things we are going to need. So instead of converting our pi to 20/7, we can just leave it as pi. Then times the radius. Now, what's the radius of this arc? So the radius of this arc is going to be 3 meters. Now, somebody will ask me, how did I get to know the radius of this arc is 3 meters? It's very simple. If you look at this triangle here, obviously this triangle is an equilateral triangle. What is an equilateral triangle? An equilateral triangle is a triangle that all the sides are equal. So if we look at the length of DE, since this is a square, then it means DE